I'm the Taborda. My student ID is 1525636. This is assignment 2, Digital Forensics, BIT362. I will explain what is a MD5 hash, and I will show how to work with it, and I will explain how to use some forensics tools as autopsy. So, what is MD5? It's a cryptographic hash function that is used to produce a fixed-site 128-bit hash value from an input data. The output of the MD5 algorithm is commonly used as a checksum to verify the integrity of data and to detect unauthorized modification to the data. This makes it useful for verifying the authenticity and integrity of digital files, as well as for creating digital signature. MD5 is widely used in various applications such as in password storage, digital certificate, and file integrity checks. Now we are going to uh, convert our student number in a MD5 hash. So in this case, we use Kali Linux, and if we can see it here, we can check. This is my student ID from Melbourne Polytechnic, and we have to use this code because this is gonna be convert uh, the string in this MD5 code. Next step is save the hash in a notepad file. In this case, we can see it here. We use the same um, MDF sum, so we can see it here and create a new document. In this case, we create hash1 and hash2 to show an example. So next one, we have to record the hash. So in this case, we use MD5 sum and use hash1 and hash2. So we got two example. Uh, this result is the same because inside of the file has the same MD5 uh, document like the previous one has this the same code. So that's why in this case the MD5 is the same. So in this case, we use three different operating systems. We use Kali Linux, Ubuntu, and Windows 7 for the different tests. So for the next one, so in this case, we change the attributes from the hash. So in this case, we have two examples. Hash2, we change the attributes. In this case, permission, just read only for all of them. We can see the MD5 change because we change the content, in this case read only, and if we can see it here, hash1 keep the same MD5 because we didn't change anything inside the document, or we didn't change the attributes. We are going to change the permission. First, let's see the file permission, file type, and the access permission by typing this code. We got this result. What does that means? Presently, we should change the permission on the hash1, in this case, this hash, and check off the change. And we are going to see if the hash value change or not, setting up some changing the permissions. So for change the permission, we are going to use this code. We can see it. The code didn't change in hash1, so that means if we change this permission or give more permission, the content didn't change. We are going to change extension. This is number 3. So in this case, we hash1 is going to change extension for that txt, like text file, and this is gonna be .exe, so like an app. So when we change the extensions, we are going to create two new files, but with the same content. In this case, the content it will be text. In this case, it's gonna be this .exe. In this port, we have to send the our hash to our emails, and after that download. And in this case, we see the hash didn't have any change because the content keep it the same. So number five, we create with this code we create a spaces. Um, as you can see on the picture, under the hash value show up, and it's not quite the same as the first hash value. Instead, show the hash value inside the file. So here we can see it. It's gonna be the same content inside our hash one. So we remove the spaces and we got the same result as previous. We just remove the spaces, but we got the same hash value like previously. Now we are going to delete the file and recover it with forensic software. In this case, we use Windows 7 and Autopsy 4.20. If we can see it here, we can't see our file because we already deleted. We create a new case in Autopsy, and we have to go to deleted files. And if we can see it here in desktop, we can see it. We our hash text one. So we just have to click right and extract file, and we can get our hash back. In this case, we can see it here. Our hash one is we already extracted, so our recovery was successful. Number seven, we have to delete the files and recover it using a backup software. In this case, we are going to use PhotoRec. When we run PhotoRec, we can choose which kind of files or which kind of extension wants to recover. In this case, we delete our hash2, so we run the software and get just the text files. In this case, we can see it. We already recovered 1,777 text files, and these files are here in our desktop. So these folders have the text recovered, so we can find our hash2 inside one of these folders. Number seven, we have to delete the files and recover it using a backup software. In this case, we are going to use PhotoRec. When we run PhotoRec, we can choose which kind of files or which kind of extension wants to recover. In this case, we delete our hash2, so we run the software and get just the text files. In this case, we can see it. We already recovered 1,777 text files, and these files are here in our desktop. So these folders have the text recovered, so we can find our hash2 inside one of these folders. In a Linux system, we have to run this code. We used Ubuntu, so when we run this code, we we was monitoring this code using Wireshark. So in Wireshark, when we send this special code, we got in our Wireshark this information. What does that means? We try to send this message. We can see the hello message here to the IP address 127.0.0.1. So the sender is our IP address, and the destination IP is 127.0.0.1. So what is the hash of the packet? So in this case, the hash is this one. We have to use the echo, the same message we send it, use the MD5 sum as well, and this is the hash we got. So what is the hash of the content? So we use this code echo minus n and our previous MD5 hash, and this is our new hash. So this is the content, the hash of the content. So in this case, our destination didn't reply. We can see it in the message because the port is unreachable. So under the P, under ICP, under ICMP, we can't get any reply. Number six. In this case, we sent the hash. We sent it 10 times, and we got the same answer for our white shark. So the destination is doesn't reply us. So the packet change, no, keep the same as previously. And number seven, imported the notify file hash imported for the software. In this case, we use autopsy, and in this case, our hash find it, but from our file name. We try to find our file by our content, but we couldn't get it. So that means we just have to search that file with the name. So in this case, we use an open content and reverse our MIDI 5 hash. So in this case, our hash reverse was successful. We can see it. This is our previous hash, and we can see it the successfully reversed. Usually, it's not that easy because the software is especially designed to don't reverse our code, our hash. So usually, it's not that easy. So in this case, our Wireshark history network, we can see it. We try to get the source from the IP address and the special port. In that case was 514. We can't reach it our port, so that means it doesn't have the connection. So now we have to learn a new tool um, that we didn't use in class. Explain how to use it, what you do with it, and demonstrate it working. So we are going to use Kane. It allows easy recovery of various kind of password by sniffing the network. So this software is so useful, but at the same time dangerous because it's gonna be sniffing your network. So you can get easily password, cracking encrypted password. For example, we can use it. We are going to use Windows 7 for this one. When we open the software, we can see it. It has different tools. For example, let's need for the network or crack the password. So it has two ways to crack the password. We can see it here. If we delete it, remove all this one and crack it, and create a new one. We have to include the password history hashes. So after that, next, and if we can see it, we can get the computed user. So that's why this software is dangerous at the same time, because if we can see it, if we can see it here, it says it's empty. So that means doesn't have password. But for example, for our password is David, and we can see this is an empty space. That means it has password. So um, so this app can really be useful to crack the password. So that's why it's dangerous. We have two options to crack the password. Once it's using this dictionary attack. What does that means? We can download an specific app from internet. For example, 10 easiest password in the world. So if we update that file, we can find the easiest password. It depends on what how your password has been set up. What does that mean? For example, if your password has lower cases, upper cases, numbers, symbols, everything is gonna be get harder to hack. But for example, in our case, this user has its password is 123456, and we are going to show how to crack using brute force. So click for this user brute force attack, and after that we have to use NTLM hashes. So we can see it here, uh, predefined. Like we can just change it if you think the password is gonna be get upper cases, lower cases, depends on a mixed number. For example, we know our password just has like numbers, so we are going to use just number ones. And the password length, we have to change it that one. Our password has six max, but for example, let's go and just use 10. So when we start the brute force, let's do it, let's start it. We can see it here because our password is so weak by security. So we can see it here how the software just cracked our password in just 1 second. So that's why we have to update and create a strong password security method. So when we start it, we just go to exit, and if we can see it, this software just show us my password, and look at we can see the user is open now. So this is the useful way to use scanning. And that's it. This is the end of the assignment. So thank you so much.